Hi there, my name's Bruce Rain from Brankus Creations, and in this video I'm going to be recapping a Macintosh Classic analog board. Just a quick reminder that if you enjoy this video, please subscribe to my channel. So I have done quite a few recapping videos, and most of them are focused around logic boards, leaky surface mount electrolytic caps on a logic board. But there are problems with analog boards too. In actual fact, all capacitors will eventually fail, and in particular, capacitors made in the 90s have a higher likelihood of failing. And this classic analog board is a very good example of that. This is, in actual fact, a Classic 2 analog board, but they're very, very similar. This is the 240 volt version, and there are differences in the capacitor values for the 120 volt version. So I've got my little cheat sheet here, the link in the description for downloading that. But this is for the 240 volt version of the analog board. The procedure, though, is pretty much the same. So this is, as I say, this is a classic, and they are renowned for leaky capacitors. And if you have a look at the back of this, you can actually see, if I bring this down to the close-up camera, you can see that a horrendous black gunk corrosion, and that is all from capacitor leakage that has seeped through, and then there's some corrosion there. Now, the hope is that it'll be repairable once I replace these capacitors and give it a clean, that it's all going to work okay. But at the moment, it's not working. So let's just have a look at those capacitors from the other side, and that's the little cluster that you can see there. Little cluster there of leaky capacitors on this analog board. So obviously one of the big differences with recapping this analog board over doing the logic boards that I do, I won't be needing the microscope because all these components are big. So I'm just going to be doing these with the sort of a close-up camera, and I'll just be going through the process that I take for removing them. Okay, so the first thing that I do when I'm recapping an analog board is I want to mark out which of these little solder blobs I need to desolder to get the capacitor off. And so I grab myself a little permanent pen and I flip the board over and I look at where all these capacitors are, and then I go in and mark out each of the little solder blobs that I am going to need to desolder. So that just involves basically flipping the board over from one side to the next and marking out each of those solder blobs, and that means that I then know which ones to start removing the solder for. So I'll do that now. Okay, so I've marked out all of my little pins there that I need to remove the solder from, and the next step now is to remove the solder. Now, if I was doing this on a logic board, I'd be using hot air to remove the surface mount capacitors, but because these are through hole, we need to actually remove all of the solder in order for the capacitor then come out. Now, you can do that with some solder wick, which I have here. So I've got some solder wick that you can then use. You apply heat. It's basically braided copper with some flux in it, and you can apply heat, and this sucks up all the solder and that draws it away. Solder wick is readily available and nice and cheap. There are links in the description. The other option you can use is a solder sucker. I've got one here. Now this is a matter of just sort of loading it up, sort of priming it like that with a spring, and then you press the button and it sucks air through this little hole. And you place that hole near the solder while it's molten and then suck the solder out. Now, these are quite cheap. They're also very dangerous. If you're not careful with them, the impact when the spring goes, you can end up actually sucking up and damaging some of the pads on the board. So I would recommend really only using this if you've got some experience with it and you're confident with using one, because if you go a bit heavy-handed with these, you can damage the board. There is a third option that I'm not including, that is to use a motorized solder sucking machine. a rework machine, and that's basically, it's like a soldering iron with a little vacuum pump, and you apply heat and then it just sucks all the solder up. They're quite expensive, so I'm not going to be using one of those today. I'm going to be using the old mechanical way, and in particular with so few of these, I think we'll be fine. So the first option I will go with will be the solder braid, the solder wick version, the wick, the Baba Yaga version of removal. So let's just grab one that I've marked out right here. I've marked out 2 pins just there and there. So I'm just going to get some of this solder wick, I'm going to put it there, apply heat with soldering iron, and in theory suck up some solder. Now that's not actually happening here, and the reason why that's not happening is because it's so badly corroded. So what I'm going to need to do, I think, with all of these is I'm going to need to apply some flux, and I'm going to need to apply some new solder because that old solder is just so scungy. So I'm just grab some new solder here, melt that on, and there, melt that on. There we go. And then let's grab some braid here and suck that up. That's working a lot better. It seems very counterintuitive to be adding solder only to remove it, but it works. That one has worked beautifully. That capacitor is basically, let me just put that away, that's just falling out, so that's fine. That's come out nice and easy. So let's do the same for the rest. So we got our basic, our steps are going to be, we're going to add some new solder, and then we'll suck up the new and old solder together. Okay, so I'm going to go and add more solder to each one of these pins. Nice fresh solder to add to the scungy old stuff. And these are all the pins that I marked out before with my permanent marker. I think that's most of them. I may have missed one, but I will, one or two, but I will come back. So once again, I'm using my braid. Now I'm not using the solder sucker on any of these, and the reason for that is that with them being so corroded, using that solder sucker could just suck the whole pad away. Okay, that's worked quite well. There we go, look at that, that fell off all by itself. So I'm just going to get rid of the old, and then we'll go to the next one. Just suck all that solder up. Give the pins a little push just to check and see that they're going through. Sometimes the capacitors get sort of glued together. They do that to prevent sort of them vibrating, and so sometimes you need to undo two for one to pop out. Okay, so I'm just going to flip this over quickly just to check and make sure that I'm removing all the right things. So there's that one, that one. This one's a bit stubborn. There we go. Okay, so there's all my caps, all my leaky caps. I mean, look at that one. I mean, that's sort of pretty horrendous, all that leakage and corrosion there. So, alright, our old caps. And of course, have a look at this as well. You can see all of those little rings there and those marks of the leakage on the board there. Okay, so they're basically the main leaky ones. Now I also remove another two. I usually remove these two here, and so I'm going to remove the solder for those. For these ones, I'm going to use the solder sucker. Now, I wouldn't dare use it on those other ones because of the corrosion, but on these ones where they're nowhere near as bad, I don't think we'll have any issue with the solder sucker at all. So, and once again, applying some solder here, and then I bring my so that solder gets all molten. Bring my sucker up to it, press the button, and that just sucks all the solder away. Let's do it with this one. Up there, put this on top, sucks the solder away. So now I should be able to. Actually, I think this one is glued, so I'll probably have to pry it from the other side. And then the last one is a little guy down here, and I'll do the same. Just going to knot the solder, suck, knot the solder, suck. There we go. Once more now. Okay, once again, we'll flip him over, and this is the other capacitor I took out. But it is, you can see it's got this sort of plastic snot holding it on, so it's going to, there we go, off she comes. Right, so they are the only capacitors that I'm going to replace. Now sure, I could go in and replace every single one of the capacitors here. One of the reasons why I don't is for, well, partly for cost. In order for me to go in and recap every single capacitor on this board works out fairly expensive, and probably more than people would be prepared to pay for a Macintosh Classic. So I basically just try and replace the ones that are known problems. These big ones here, I've never known for these to fail. And same with these ones up here. There doesn't seem to be any real issue with these ones. Certainly in the ones that I have worked with. I have actually gone in and replaced every single capacitor on one of these boards before, and it worked exactly the same as the one where I'd only replaced these ones. So that's the general gist. So I'm going to just grab some isopropyl alcohol and a toothbrush here, and I'm just going to clean some of this off. Some of this scunge off from under here. There we go. A little bit more. Okay. And tissue there. Right. So, next step is to put some new capacitors on. Okay, so the next step is to replace these capacitors. So I'm basically just going to feed these through the hole, making sure that I get the polarity correct. I'll start off with these two here at the front, which are 470 microfarad 25 volts. I've got one here, I've got another one there. Now these are all labelled with the positive, and obviously on these capacitors the negative is marked, and the so we've got the stripe to mark the negative, and you've generally got a longer pin on the positive. So so basically I can just get this and I can pop the positive through the positive hole and do the same with that one. Okay, now obviously I need to solder it from the other side, and when I do that, if I flip them over, they're going to fall out. So what we do is we just get these pins. Where am I here? We just get the pins and just give them a bit of a bend, and that just stops them from falling out, just holds them in position. Okay, so that's those ones. So next we have a 1000 microfarad 10 volt, just one of those. That's here. So I'm going to get that, I'm going to feed that in here, positive in the positive hole. Yep. Okay. Okay, so that's that little cluster, all ready to go. next step is to solder them. Now, what I usually do with these is I solder one side of each one. And the reason why I do that is because I like them to be sitting nice and flush to the board. So I solder one side, and then I push them up from the other side while the solder is molten, and then let the solder cool, and that just holds them in position. So I'm going to just demonstrate that now. So I'm just going to put solder onto to one side of each of them. Okay, so then one at a time, I'm basically going to just put my hand underneath here like this. I'll just, one at a time, I'll just push down on the capacitor while I melt the solder on the other side. And so it will then just allow me to make sure that that's flush. Okay, so that's flush. Let's go to this one. I'll give it a wiggle. That's the one it is. Melt that. Now you can see that one was not quite flush, so now it's flush. This one here. Flush. Right, am I wiggling the right one? No. That's the right one. Okay. So they're all reasonably flush. Next step now is to solder the other side. So let's do that now. Right, now that they're all soldered, I then just need to cut off the excess pins. Just be mindful of where they go, because you don't want them to end up getting stuck to the magnet in the speaker or ending up somewhere in the computer they're not meant to be. As long as they're away from the computer, I don't really mind where they end up. Off. Okay, now I do need to address a couple of issues with this. What I have noticed as I was soldering these is there are a couple of these pads that are so badly corroded the solder's not taking to them very well. So I'm going to have to go in and clean those up a little bit, and I'm going to do that by generally scraping them with a scalpel and to just try and expose some nice fresh copper, and then I'll be able to put some solder on them. What I've also discovered is that there are some pads that are actually literally falling off this board because of the damage, namely one right here. So I'm going to have to probably go in and do some trace repair to this as well, put in some wire here to replace this really ugly falling apart trace. So I'm going to do that now, and then we'll see how we go. Okay, so that's all of the capacitors replaced. I have had to do some trace repair. We've got just here, I have sort of added a little wire in here to join between here and here, and I'm confident that that's going to do the job. And right here where you can see a great big massive solder blob, that's where we lost a bit of pad, and so I'm using that solder blob to sort of bridge the missing part. So that's doing the trick there. So all of those capacitors are done. The next step now will be to try and clean this board as best as I can, and then put it into a computer and fire it up and see what happens. Okay, so here is the board after cleaning, and it's no thing of beauty, but I definitely think it might work. Maybe. So I'm going to put it all back together and we'll see what happens. Okay, well, it's all put back together. Analog board is in, logic board is in, power is connected, and so now we'll just see what happens. Oh my goodness, look at that. We got a chime. Hey! Once again, with these, we've got some geometry issues here. The screen's a bit squished down. I'm going to have to stretch it out, which is fine. That can all be done with the little twiddly controls on the back here. So, and I would be very surprised if it booted, because it's got an old spinner hard drive in here, and I would be almost certain that that's probably Cactus by now. But yeah, and we're getting a flashing question mark. Hardly surprising, you know, with an old hard drive like this. But I have to say, that's an extremely rewarding recap of that analog board, because it was in such a mess. But now it's back to working, and so thanks for watching.